As we haven't specified the way our buttons are supposed to behave, certain values have been chosen automatically. We have it set that the button should take up the entire width and only the height it needs. As we can see, when using this method, it's necessary to enter a lot of code if we have more than one layout. This is because the subsequent layers of depth have to be carried out by creating other layouts, nesting them inside one another. If we wanted to have two buttons, one under the other, and additionally two buttons next to them, we'd have to create a new linear layout, package the buttons in it, and place it in the layout we currently have. That is why the creating of views with the use of XML files is an approach which is much more often used. In such cases, we use the setContentView method by sending the ID of the resource used to build the entire view hierarchy to it. Access to resources from the level of the Java code is obtained by calling the specially generated R class, which includes an internal ID class. This class, in turn, has specific fields for specific resources. In our case, we're interested in the R layout subclass, which includes the activity hello. Note that it's nothing more than an ordinary integer. If we want to see what is actually created in this class, we have to go to the build folder and the generated subdirectory. They include files generated by Android Studio. For instance, there are source directories which include source files generated with resource. Under our package name, we have a specially generated R file. It shouldn't be modified because it will be overwritten in case of any change. However, it's good to know what is inside that file. There is a class named R, which is created inside our package. This is a class which includes subclasses that correspond to the types of resources we have. Now we use the following resources: dimension, drawable, ID, layout, menu, string, and style. Each resource present in the file system corresponds to a specific field inside one of these classes. In our case, we have a special constant with a unique resource identifier defined in the layout class. Thanks to that, the system is able to decide at the Java code level which resource we want to refer to. The moment the setContentView is called, two things happen. First of all, we can use the inflator mechanism, which is obtained by calling getLayoutInflator, to get an object which can process XML files into views. Its task is to parse the layout file and create a full view hierarchy based on it. Calling setContentView actually calls the getLayoutInflator.inflate method. The resource we want to build is transferred here. The created full view hierarchy is transferred as a view to the setContentView of a lower level, which takes the view as a parameter. In the XML file, we actually have a single main layout, which includes a text view. Thanks to this, we have less code to write. We can now describe the relationships of nesting one view in the other. Now, if we want to create a layout which includes another layout, we can place the linear layout inside, specifying the relevant parameters. We may even place other elements inside. This causes the structure we have written to be automatically created. We'll get a button packaged in the linear layout, the text view, and the relative layout, including both components. Now, we should mention the method of referring to the resources we have in the system. I've already shown you the version where we refer to a resource via the R class in the Java code. This is a basic method in terms of access from the Java level. This way, we can easily access ID fields, texts, or layouts. The second approach is using dependencies between the resources inside the resources themselves. In the case of XML files with layouts, we may refer to certain resources which were defined in other files. For instance, if we have a button or a text view, we can specify the text that is to be displayed by using text equals @string/name.